कम हियर तुहानू ठीक है विजिबल है आओ जी तुसीं पिछे वाला इधर आओ सिट हियर कॉपी पेंसिल लैके इत्थे आओ सीख लो कुछ Why are you late? What is the time? Time दस भी कितना मेरे तो पहला लंच ब्रेक होंगी है तो फिर लेट आना बच्चों अगे तो अलाउड नहीं करना मैं है इत्थे बह जा बट अगे इन्हों भेज बाकी इत्थे बैठो ना तुम विचाले सीटा ला दो फटाफट आओ yesterday we talk about the principles of dimensioning if anybody having any doubt if you don't have any doubt we will continue with the scales and this is the topic which we will discuss today scales एक तुसी तुहाडे कोल स्केल हुंदी है you might have seen the scale तुहाडे ड्राफ्टर ते एक स्केल बनी हुंदी है अदरवाइज भी लोअर क्लास जो ड्राइंग का सबजैक्ट पढ़िया होवे तो तुहानू ना कई तरह दी गत्ते दी स्केल्स हुंदियां सी उन्हां उत्ते कुछ लिखिया हुंदा सीगा ਉਹ ਵਾਲੀਆਂ स्केल्स भी ਜਿਹੜੀਆਂ ਨੇ you made different types of scales by making use of the RF and what is RF that is called representative fraction I give you one example later to the scales why is it so important ਤੁਸੀਂ ਨਕਸ਼ਾ ਦੇਖਿਆ have you ever seen the word map ਜੇ word map ਦੇਖਿਆ ਉਹ word map ਇੱਕ ਤੁਹਾਡੀ ਜਿਹਨੂੰ ਕਹਿ ਲਈਏ ਕਿ ਸ਼ੀਟ ਤੇ ਆ ਜਾਂਦਾ ਆ you are able to get the word map on a sheet ਉੱਥੇ scale ਦੀ application use ਕੀਤੀ ਆ otherwise it's not easy to draw the map or word map similarly if you go with the contingent map ਕੰਟੀਨੈਂਟ ਦੇ ਮੈਪ ਜੇ ਬਣਾਓਗੇ ਉਹ ਵੀ ਜੇ 7 ਕੰਟੀਨੈਂਟ ਨੇ ਤਾਂ ਉਹਦੇ ਵਿੱਚ ਵੀ ਅਲੱਗ-ਅਲੱਗ ਮੈਪ ਨੇ you can't make these map without the help of scales is it okay or not I give you one more example ਤੁਸੀਂ ਇੱਕ ਦੇਖਿਆ here we put a pin ਜਿਹਨੂੰ ਪੱਗ ਪਿੰਨ ਬੋਲ ਦਿੰਦੇ ਨੇ the size is very very small ਜੇ ਤੁਸੀਂ ਉਹਨੂੰ ਬਣਾਉਣਾ ਹੋਵੇ ਪੱਗ ਪਿੰਨ ਨੂੰ ਤੁਸੀਂ ਇੱਕੋ ਪਿੰਨ ਬਣਾਣੀ ਆ ਬਾਕੀ ਡਰਾਇੰਗ ਸ਼ੀਟ ਤੇ ਤੁਹਾਡਾ ਪਿੰਨ ਨਹੀਂ ਬਣਾਣੀ ਫਿਰ ਕੀ ਹੋਏਗਾ in that case you will make use of a scale ਤੁਸੀਂ ਜ਼ੂਮ ਕਰਕੇ ਕਈ ਵਾਰ ਕਈ ਚੀਜ਼ਾਂ ਨੂੰ ਦੇਖ ਲੈਂਦੇ ਹੋ in your computers sometimes you make use of the zoom command in with the help of the computer ਉਹ ਕਿਉਂ ਕਰਦੇ ਹੋ or sometimes what you do ਤੁਹਾਡਾ ਨਾਰਮਲ ਹੁੰਦਾ 100% ਕਈ ਵਾਰ ਉਹ 70% 75% ਹੁੰਦਾ ਆ ਉਹ ਰਿਡਿਊਸ ਹੋ ਕੇ ਡਾਕੂਮੈਂਟ ਦਿਖ ਰਿਹਾ ਹੁੰਦਾ and if you keep on increasing 125% ਉਹ ਡਾਕੂਮੈਂਟ ਹੁੰਦਾ ਉਨਾ ਹੀ ਹੈ ਬਟ ਸਾਈਜ਼ 'ਚ ਵੱਡਾ ਹੋ ਕੇ ਦਿਖਦਾ ਹੁੰਦਾ ਉਹਦਾ ਦੀ ਜ਼ਰੂਰਤ ਕੀ ਆ why is it so important ਕਿਉਂਕਿ ਉਹਨਾਂ ਦੀ ਜ਼ਰੂਰਤ ਇਸ ਕਰਕੇ ਆ ਕਿਉਂਕਿ ਤੁਸੀਂ ਉਹਨੂੰ ਉਸ ਡਾਕੂਮੈਂਟ ਨੂੰ ਲਾਰਜ ਕਰਕੇ ਈਜ਼ੀਲੀ ਰੀਡ ਕਰ ਸਕੋ that is the important of scale scale ਜਿਹੜੀ ਆ ਤੁਹਾਡੀ 3 ਤਰ੍ਹਾਂ ਦੇ ਤੁਸੀਂ ਰਿਪਰੈਜ਼ੈਂਟੇਸ਼ਨਸ ਕਰਦੇ ਹੋ you make use of 3 types of represent in the scales ਉਹ ਕਿਹੜੀਆਂ 3 ਰਿਪਰੈਜ਼ੈਂਟੇਸ਼ਨ ਨੇ one is called normal size normal size ਕੀ ਆ 1:1 and what is this 1:1 ਇਹਦੇ ਲਈ ਇੱਕ word ਤੁਸੀਂ ਯਾਦ ਰੱਖਣਾ ਬੱਚਿਓ that is called RF is nothing basically representative fraction in some of the books you will find the representative factor also there is another term SOF भी same चीज आ इनू SOF and RF one and the same thing but SOF is scale of factor this decide which type of scale is there so this is the normal size RF is this is the definition of RF this is length of a line in the drawing length of a line in the drawing to the actual length of the object. Length of a line in the drawing to the actual length of the object. Actually, this 1:1 is 1 by 1. Am I right or wrong? ਇਹਨੂੰ 1/1 ਵੀ ਕਹਿ ਦਿੰਦੇ ਆ. What is 1? 1 means length of a line in the drawing. What is on the right hand side of this dot? Ratio. This is the actual length of the object. If I say 100:100, it is nothing, basically 1:1. And so far what we have discussed, what is the minimum dimension which can be measured with the help of a drafter? Mm. Minimum dimension is millimeter. And if you write down capital M, this becomes mega. 10 raised power 6, 10 raised power 6. So please don't write capital mm. This is small mm, millimeter. This is the representation by which you can make use of mm. Another size, another one. Then reducing size or reducing scale. What is that? This is 1:x. 1:x, where x is greater than 1. 1:x, where x is greater than 1. Let us assume I write down 1:2. Here x is greater than 1. Is it okay? What does it indicate? It indicates that length of a line in the drawing is 1 and actual length is 2. Basically, your actual length is 2 times than that of the length of a line in the drawing. So here we make use of a reducing scale. And the third one, if I write down 1:100, what does it indicate? Length of a line in the drawing is 1, actual length is 100. If it is 100 centimeter, it is represented by 1 centimeter. Is it okay so far or not? किसी बच्चे दी कोई doubt हो? Another thing, then is called enlarging scale or enlarging representation or enlarging size. You can use any of the words here. Again, x ratio to 1. X ratio to 1, where x is greater than 1. If I write down 2:1, what does it indicate? It indicates that length of a line in the drawing is 2 and actual length is 1. ਅਸੀਂ ਜਿਹੜੀ ਮੈਂ ਪੱਗ ਪਿੰਨ ਦੀ ਐਗਜ਼ਾਮਪਲ ਲਈ ਸੀ, ਜਾਂ ਪੈਨ ਜਿਹੜਾ ਤੁਸੀਂ ਬਣਾਉਂਦੇ ਹੋ, ਜੇ ਪੈਨ ਦੀ ਬਣਾਉਣੀ ਜਾਂ ਇਰੇਜ਼ਰ ਦੀ ਬਣਾਉਣੀ ਹੋਵੇ ਜਾਂ ਸ਼ਾਰਪਨਰ ਦੀ ਬਣਾਉਣੀ ਹੋਵੇ, ਉਹ ਸਾਰੀਆਂ ਚੀਜ਼ਾਂ ਨੂੰ ਤੁਸੀਂ ਅਨਲਾਰਜਿੰਗ ਸਕੇਲ ਤੇ ਕਰਦੇ ਹੋ. ਵਰਡ ਮੈਪ, ਕੰਟਰੀ ਮੈਪ, ਸਟੇਟ ਮੈਪ, ਕਾਲਜ ਮੈਪ, ਈਵਨ ਤੁਹਾਡੇ ਘਰ ਦਾ ਜਿਹੜਾ ਤੁਸੀਂ ਬਣਾਉਣਾ ਹੈ ਮੈਪ, ਉਹ ਸਾਰਾ ਤੁਸੀਂ ਰਿਡਿਊਸਿੰਗ ਸਕੇਲ ਤੇ. ਮੈਕਸਿਮਮ ਟਾਈਮ ਯੂ ਵਿਲ ਮੇਕ ਯੂਜ਼ ਆਫ ਦਾ ਰਿਡਿਊਸਿੰਗ ਸਕੇਲ. Very limited you will make use of this enlarging scale. And when to use the enlarging scale? When we are having a dimension very smaller one, and you are left with on a sheet, you are left with more space available on the sheet. In that case, you can make use of this enlarging scale. Now here, if I write down 100:1, what does it indicate? Length of a line in the drawing is 100, actual length is 1. This is very important definition. Representative fraction. In some of the books you will find a representative factor also, but this is basically a representative fraction or scale of factor. This is one and the same thing. Again, length of a line in the drawing to the actual length of the object. There are two things which are important in the case of the scales. There are 6 types of scales which are there. There are 6 types of scale which are there. One is plane scale. Another one is diagonal scale. Another one is comparative scale. Another one is vernier scale. Okay. Another one is isometric scale. Another one is scale of chord. Scale of chord. We'll discuss only first two in our class. Plane scale and diagonal scale. बच्चों एक गल का होर ध्यान रखियो, there is another word plane. This is also a plane, but this plane there is a lot of difference between these two words. One is plane, another one is plane. We'll discuss these two in subsequent classes. Today, don't write down plane plane scale. This is plane. This is the plane. So we'll discuss first two in our class. Rest are not in our syllabus, but if you are interested, we'll share the information with you later on also. Now, in plane scale, if you are going to measure meter, centimeter, if you are going to measure up to 2 unit, meter, centimeter, or meter, basically meter, decimeter, centimeter, millimeter. At a time you are choosing only two, meter, decimeter, or decimeter, centimeter, or centimeter, millimeter. Then you can use plane scale. Is it okay? 1 meter, 10 decimeter. 1 meter is equal to 10 decimeter. 1 decimeter is equal to 10 centimeter. 1 centimeter is equal to 10 millimeter. If you look at here, only two dimensions are used, meter, decimeter, or decimeter, centimeter, or centimeter, millimeter. So here you can make use of the plane scale. And another thing, if the dimensions are meter, decimeter, centimeter, you are using three components simultaneously, meter, decimeter, centimeter. Here you make use of the diagonal scale. Is it okay or not? Or decimeter, centimeter, millimeter. Again, this will make use of a diagonal scale. And when you are doing the comparison between the time and distance, when we are making the comparison between time and distance, you can make use of the comparative scale. You can make use of the comparative scale. Vernier scale. You might have seen the vernier scale on a vernier calipers. One main scale division is equal to one vernier scale division. On which principle the vernier is designed, that scale is known as the vernier scale. This isometric scale means, iso means equal, metric means measurement. When we are going to measure all the three dimensions, length, breadth and height, that becomes the isometric scale. The beauty of this one is you will get all the three dimensions, length, breadth and height, in a single scale, that is called the isometric scale. Scale of chord. What is chord? If you look at this circle, this is the circle. If you take 2 points on a circle, if you join it with a straight line, and this straight line should not pass through the center of the circle, that is called this is called AB, scale of chord. And if I put down AB symbol like this one, this becomes the arc. So this is the difference between, here you can make use of the scale of chord. This is the basic principle. In detail, we will discuss this plane scale and diagonal scale. Is it okay or not? So how to draw plane scale and diagonal scale, we'll take one or two example each. May I rub it? Okay. Now here, I keep this definition as it is, and you can write down one problem related to that one. Please write on one problem related to that one. It will help you a lot. Construct a plane scale. Construct a plane scale of 1 meter is equal to 0.5. 1 meter is equal to 0.5 meter. Construct a plane scale of 1 meter is equal to 0.5 meter to show single meter, single decimeter, to show single meter and single decimeter, and long enough to measure up to 8 meter, and long enough to measure up to 8 meter. Show a distance of 7 meter 5 decimeter. Show a distance of 7 meter 5 decimeter and 6 meter 3 decimeter on it. Now, how to solve this problem? First of all, this is a plane scale problem. It is clearly mentioned this is a plane scale. Construct a plane scale. When it is a plane scale problem, you are going to construct, there are two things which are important before drawing any scale. First of all, you need to calculate RF. RF is nothing, basically the representative fraction. Here 1 meter is equal to 0.5 meter. यही लिखे ना मैं. Now here basically this becomes 1 over, you will convert into this one 1 over 0.5. Sorry, I have mentioned 1, not 1 meter. This is 1 centimeter is equal to, sorry, 1 centimeter is equal to 0.5 meter. 1 centimeter, it represents 0.5 meter. So you are going to basically, you are going to, first of all, what to do? 1 centimeter equal to 0.5 meter. 1 centimeter is equal to 0.5 into 100. Now both the units are same on both on side. Is it okay or not? So here you will get, what you will get, 1 centimeter is equal to 50 centimeter. So your RF will be 1 over 50. Your RF is 1 over 50. And what is LOS? This is called length of scale. Length of scale. This is the second parameter which is important. And the formula of length of scale is equal to RF into maximum distance to be measured. RF into maximum distance to be measured. And what is RF? 1 over 50. And here maximum distance to be measured is 8 meter. Here maximum distance to be measured is 8 meter. Into, what are the units of RF? No. This gets cancelled. Centimeter gets with cancelled with centimeter. So there will be no unit. No unit. This is the important part. There will be the no unit of the RF. It is applicable in all the cases. It will be applicable. And if this RF has no unit, and what is the unit of this one? 8 meter. Can I measure meter value with the help of drafter? Does your drafter support the meter value? Your drafter does not support the meter value. What is the value it is supporting? Centimeter or millimeter. Centimeter or millimeter. It is better if I multiply with 100. ਇਹ ਹੁਣ ਕਿਸ ਦੇ ਵਿੱਚ ਬਣ ਗਿਆ? It becomes the centimeter. If I keep on calculating 16 centimeter. 16 centimeter. ਹੁਣ ਤੁਸੀਂ ਕੀ ਕਰਨਾ? ਸਭ ਤੋਂ ਪਹਿਲਾਂ, may I rub it? Okay. I'm going to rub this one. Take a 16 centimeter line. Take a 16 centimeter line. Draw an acute angle. Draw an acute angle. What is the beauty of acute angle? It is always less than 90 degree. And divided into 8 equal parts. Why? 1, 2, 3, 4, 5, 6, 7, 8. Is it okay or not? Join this last part with this last one. Your drafter will be set parallel to this one. Draw rest of the line. Clear? Now here, take 1 centimeter or 10 mm. Basically, it will look like a shape like this one. This is a 1 centimeter or 10 mm. You will have a scale like this one. Another thing, from here, drop the perpendicular. This is basically a perpendicular. Do it for all the points. Now what happens? If I do the numbering system from here, this is 0. 0 meter, 1 meter, 2, 3, 4, 5, 6, 7. It is in meter. It is clearly mentioned here. Can anybody read me the same problem again for me? Construct a plane scale of RF. 1 centimeter is equal to 0.5 meter to represent single meter and single decimeter, and long enough to measure up to 8 meter. Also show the distances of 7 meter, 5 decimeter and 6 meter, 3 decimeter. This is what I have asked. 6, 3, 7, 5. Now, does it represent single meter? Single meter, single meter, single meter, single meter, single meter. That is why I have divided into 8 equal parts. Is it okay? If I divide it into 6 equal parts, what happens? Each must not have represent single meter. 8 by 6. If I represent into 16 equal part, each will represent 0.5 meter. Is it okay or not? Now, what happened? Now, I again take a acute angle. Then divide this line into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it okay? When I join this point with this line, why I have started 0 from here? If I start the 0 from here, now I can measurement all the dimensions vary from 0 meter to 8 meter, representing single meter and single decimeter. If I start 0 from here, I am going to measure only 8 meter. Is it okay or not? So that is why we will always start 0 by leaving one block blank. We will give the numbering from here 0, 1, 2, 3, 4, 5, 6, 7, 8. Now, this is the line. Your drafter will be fixed according to this line. You will have a parallel lines according to this one. How many lines will be there? 10. Why? Because it represents a single decimeter. If I keep on joining single decimeter 10 times, what will happen? So on. It will become 10 decimeter, and 10 decimeter is equal to 1 meter. Is it okay or not? So, you will put in between a center line, dividing this into 2 equal parts. Is it okay? Now, you will have a line like this one. Make again the perpendicular lines from these points. These are 10 in number. Another thing, this represents your decimeter, single decimeter. When I divide into 10 equal parts, this becomes a 10 decimeter. When I move from right to left, right to left on shorter scale, the value will increase. The value will increase. When I move from right to left on a shorter scale, your value will increase. This is 1 decimeter, 2, 3, 4, 5, 6, 7, 8, 9, 10. Clear? You will have a 10 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Clear? Clear? Similarly, when you move from left to right on bigger scale, your value will increase. 0 is here, 1 is here, 2 is here, means it is increasing. Clear? Huh? Oh, this is from right to left. Right to left. I have mentioned right to left. Now, look at here. You are going to represent 7 meter. This is the 7 meter. Up to here, this is 7 meter. 1, 2, 3, 4, 5. And leave in between some distance. Again here, yesterday we have already discussed the principles of dimensioning. Again, we are making use of the extension line. Whatever we learned yesterday in a class, we are going to apply today in a class. Now, this is the dimension line. Rub it. Don't make it beyond 2 or 3 mm. This is 7 meter, 5 decimeter. I have committed one mistake. What? Initially, I have to show the smaller one, then the bigger one. What is the smaller one? 6 meter. 6 meter is the smaller one. 6 meter here, then 3 decimeter. This is the 3 decimeter. First of all, show the smaller one. Otherwise, 3 decimeter. And here it is 7 meter, 5 decimeter. 7 meter, 5 decimeter. And another thing, this is all about your problem. What are the part which has to be dark? Only this color chalk is the dark one. For your convenience, you can draw these also dark, these lines which represent a meter. Or some of the lines related to this one, few of the lines you can also show. So this is all about your problem. Another thing, you are going to write down, this is the darker one. Make use of this one. This is the darker one. Now, what are the things which you have to be? Please write down RF here. This space, the RF was 1 over 50. Make use of the guidelines and then write down 1 over 50. Then what is LOS? LOS is 1 over 50 and show all the calculation into 8 into 100. It is equal to 16 centimeter. Again, make use of the guidelines. When you are comfortable on it, then you can ignore. Otherwise, make use of the guidelines. Is it clear? These are the things which you must write down. Here, the space which is left here. You can draw this one. Earlier, you can make the calculation in a rough, and later on, you can shift all the value. If you don't write down these values and you are able to draw this one, you are not able to get the full credit. because once you are able to make use of these things, only then you can draw this one. ਸਮਝ ਆ ਰਹੀ ਹੈ ਗੱਲ ਕਿ ਨਹੀਂ? ਜੇ ਤੁਸੀਂ ਆ ਚੀਜ਼ਾਂ ਮੈਂਸ਼ਨ ਨਹੀਂ ਕਰੋਗੇ ਤੇ ਤੁਸੀਂ ਇਹਨੂੰ ਬਣਾ ਦੋਗੇ ਤਾਂ ਕੋਈ ਫਾਇਦਾ ਨਹੀਂ। ਕਿ ਜੇ ਇਹ ਬਣਾਤਾ ਬਹੁਤ ਸੋਹਣਾ ਬਣਾਤਾ ਬਟ ਆ ਨਹੀਂ ਲਿਖਿਆ, I'm not going to give you the full credit, ਕਿਉਂਕਿ ਮੈਨੂੰ ਇਹੀ ਨਹੀਂ ਪਤਾ ਲੱਗਿਆ ਆਹ RF ਕਿੰਨਾ ਸੀ ਤੇ LOS ਕਿੰਨਾ ਸੀ, ਮੈਨੂੰ ਤਾਂ ਪਤਾ ਹੀ ਨਹੀਂ ਲੱਗਿਆ। ਫਿਗਰ ਤੁਸੀਂ ਬਣਾਤੀ ਬਹੁਤ ਸੋਹਣੀ। ਸਮਝ ਆ ਗਈ ਕਿ ਨਹੀਂ ਆ ਗਈ? ਇੱਥੇ ਤੱਕ ਕਿਸੇ ਬੱਚੇ ਦੀ ਕੋਈ ਡਾਊਟ ਹੋਵੇ?